This is a video that NIBA's manufactured that is really nice. They've spent quite a bit of money on this over the years. And it goes through, it's a maybe 6-8 minute video. It goes through heavyweight belt tracking, lightweight belt tracking, and it explains the process, how it's done. It's pretty graphic little video. It's pretty nice.
Belts in motion, moving raw material and finished goods quickly and efficiently. The conveyor belt is the lifeline, the main link to industrial production. But a conveyor belt is only as good as the system it performs on. Properly loaded, well tracked, and operating on properly serviced idlers and pulleys, a conveyor belt will deliver a long, productive service life. A conveyor belt that tracks properly should be the ultimate goal for the conveyor user. To achieve proper tracking, certain practices are crucial. This program will focus on basic procedures that will help ensure proper belt tracking. The first segment will concentrate on the general mechanics involved in the tracking of all conveyor belts. The second segment will focus on tracking issues for lightweight belts, meaning belts with a designed maximum operating tension of less than 160 pounds per inch of width. The third segment will focus on tracking issues for heavyweight belts, meaning belts with designed operating tensions equal to or greater than 160 pounds per inch of width. For more detailed information on belt tracking, consult the NIBA Technical Handbook. Tracking is defined as the procedure required to make the conveyor belt run true when empty and also when fully loaded. This is also referred to as training. Conveyors which do not track properly cause material spillage, component failure, higher maintenance costs, costly damage to the conveyor belt itself, and possibly a total shutdown of the system. When a conveyor belt is installed, problems of design, manufacture, erection, poor workmanship, and normal tolerances become apparent. All too often, these problems are considered belt problems. The belt may well be at fault. Belt conditions that contribute to mistracking include belt camber, skew or bow, too low belt tension, failure to properly square the belt ends, poor installation of mechanical fasteners, or an improperly executed belt splice or vulcanization. However, a mistracking belt is more likely reacting to a structural defect or maladjustment in the system. Therefore, the problem of tracking should be approached as much from a systems point of view. One fundamental condition must exist for a conveyor belt to track properly. This condition is a square conveyor system. The support structure, pulleys, snub rollers, carrying idlers, and return idlers must all be square with the frame and parallel to each other. Another very important aspect for proper tracking is the possibility of material buildup. Excessive material buildup on rollers will cause tracking problems to develop. The cleanliness of the system is therefore critical for good tracking to take place. Tracking the belt is a process of adjusting idlers, pulleys, and loading conditions in a manner that will correct any tendencies of the belt to run other than true. A normal sequence for belt training is to start with an empty belt and begin with the return run working toward the tail pulley, followed with the top run in the direction of belt travel. Tracking adjustment is done while the belt is running and is concentrated over a length of the conveyor preceding the region of trouble. The priority should be given to adjusting idlers first, followed by adjustment of pulleys and snub rollers. There is one basic rule to remember when training a belt. The belt moves toward that end of the roller or idler it contacts first. Training a belt by adjusting one or more idlers is like using the handlebars to steer a bicycle. Looking down the direction of belt travel, when you shift an idler as you would the handlebars, the belt will move in the same direction as the bike would. The adjustment may not be immediately apparent, so permit the belt to run for several minutes. For longer belts, wait at least 3 full belt revolutions after each idler adjustment. Then determine if additional tracking is required. If the belt runs to one side at a particular point or points on the conveyor structure, there are three probable causes: the alignment or leveling of the structure, the idlers or pulleys immediately preceding that particular area, or a combination of these factors. If a section or sections of the belt run off at all points along the conveyor, the cause is possibly in the belt itself. The belt ends may not have been squared properly, or off-center loading may affect the tracking. After the empty belt tracking is completed, run the belt with a full load and recheck the tracking. Ideally, loading should be done in the center of the belt. Some conveyor systems incorporate equipment or arrangements to limit, correct, or forestall mistracking. The most widely used automatic tracking devices are movable guide arrangements. These include vertical rolls, flanges, or tracks used as guides. They are normally used with low belt tension applications. Other devices try to detect mistracking when it occurs and then take corrective action. A variety of designs include optical, electrical, hydraulic, or pneumatic sensing devices to control actuators that tilt a roller. These arrangements are expensive to install and maintain. All the automatic tracking devices work under the handicap of being after-the-fact arrangements. Some preset amount of mistracking must occur before any limiting or correcting action is begun. One very popular solution to mistracking is solved by the crowned pulley. Crowned pulleys are effective when used with low tension and very short conveyor systems, restricting their use to lightweight belts only. Heavyweight belts generally operate with a troughed roller arrangement. These belts utilize high-tension fabric and/or steel cord construction. The use of crown pulley arrangements can cause damage to high-tension belts and are therefore not recommended. Crown pulley arrangements will be examined in Section 2 of Belt Tracking, Tracking Lightweight Belts. Lightweight and heavyweight conveyor belts share many similar characteristics when it comes to belt installation and tracking. However, some factors are restricted to lightweight belting. One such factor is the pulley crown. A pulley crown features a larger diameter at the center than at the ends. The effect of this design is to direct the belt to the center of the pulley, thus acting as a tracking device. Crowns are most effective in applications where there is a long span approaching the pulley. Head pulleys, tail pulleys, and take-up pulleys are best suited for crowns. The larger the pulleys and the higher the belt wrap, the more effective the pulley crown. There are three general types of pulley crowns. The radial crown is suitable for lightweight rubber and PVC belting, as well as European-style monofilament belts having a width of 8 inches or less. Trapezoidal pulley crowns are best suited for European-style monofilament belts over 8 inches in width. Apex or hip crowns put unnecessary stress on the center of any belt, contributing to shorter belt life. This crown design should be avoided. Recommendations for crown geometry differ slightly between belt manufacturers. For more information, consult the pulley and belt manufacturers. Another important factor that is specific to lightweight belting, particularly European monofilament belts, is proper belt tension. To get proper tension, a very simple method is used. First, determine the correct amount of tension. In this example, we want to achieve 0.6% belt tension. With the belt installed and without any tension, make 2 marks on each edge of the belt, a measured distance apart. In this case, 40 inches apart. Slowly and evenly start tensioning the belt until the marks have moved or stretched apart to the predetermined amount of tension. In this case, when the marks have stretched to 40.24 inches, the entire belt has 0.6% tension on it. Heavyweight belt applications present certain training needs that are not found in lightweight applications. One such need is the training aid. Training aids such as self-aligning idlers, edge guides, and limit switches act as a form of insurance against severe training problems that go undetected. These training aids are temporary because they affect basic training problems that should be corrected immediately. The vertical edge guide is a popular training aid that places spools or rollers a few inches from the belt edge. Rather than prevent belt wander, they perform a damage control function, allowing the belt to strike a rolling surface rather than a fixed surface. The guides tend to wear off the belt edge and cause ply separation. Therefore, persistent contact is undesirable, and the source of the problem should be located. Another important training aspect for heavyweight belts is the return idler. Usually, the troughing idlers on the carrying side exert a natural training influence and are generally sufficient to maintain belt position. The return side presents the most serious condition for belt damage due to its confined position within the structure. Of the different types of return idlers, only the V-return idler exerts a positive training influence on the belt. This idler offers constant belt contact and is highly recommended on conveyors over 500 feet in length. The other return idler types, flat and flat disc, offer no training influence but are acceptable with additional training idlers as needed. The spaced disc idlers should have 6 to 8 inches of solid ends. This is necessary to prevent trapping the belt edge between the discs. Another factor common to heavyweight belts is material buildup. Excessive material accumulation on idlers and pulleys will simulate components that are out of alignment and actually act like a crowned pulley. The belt will try to center itself over this crown, causing belt wander. Buildup also causes unequal tensions across the belt width and is detrimental to belt life. Special care must be exercised to keep return rolls, snubs, and other pulleys clean. An effective multiple cleaner belt cleaning system should be installed to prevent material carryback. If necessary, belt cleaners can be installed directly on the snub and other pulleys. For more information on tracking issues specific to both lightweight and heavyweight belts and troubleshooting issues, consult the NIBA Handbook. As the cost of conveyor belts increases, the need for proper belt tracking becomes crucial. A belt that is properly installed and centered will deliver high performance and a long life to any application. Belt tracking, a key to productivity, a key to keeping your belt in motion.
If anybody's interested in that video, NIBA sells it, so you can take your money and send you one. I don't know if you have any with you or not. It's on DVD as well. So sometimes we sell these people that make sales calls with customers and want to train their end user a little bit, quick little luncheon thing. So it's a pretty popular thing to sell.
We're going to just recap it quickly. Tracking is a process of adjusting idlers, pulleys, and loading conditions in a manner that corrects the off-running. So if you have a system where you're having tracking problems, you make these corrections to get it going properly. Actually, they talk about training and you talk about tracking. A belt tracks, and the thing you do to get it to track properly is train it. So that's why they use those two in conjunction with each other. Tracking should begin on the return side, near the head pulley, and move towards the tail. The reason for that being, in a trough conveyor system, the whole philosophy is if you can get the belt running straight through the tail pulley, and you're loading down the center of the belt, on the carry side, your idlers will keep the belt where it needs to be and it'll run straight. You track the belt empty first. That avoids a lot of things, like what happens when your belt, when you load the belt, if you load an off center a little bit or such. You don't have, if you're running the belt empty to try to track it, you don't end up with product all over the ground and serious other problems that can be avoided. If you can track it empty, you can more than likely track it while it's full, because empty is the point where you have the least amount of weight in the system and the least amount of control over the belt. So if it tracks empty, unless you're doing something very seriously long. When you load it, it should run straight loaded. We've talked about making the adjustments prior to the region of trouble. You figure if you see a belt running off, you don't run right to that spot. You go about 15, 20, 30 feet, wherever you have to go down prior to that point, and begin making adjustments and checking your conveyor system. Check it for level, check it for square. Now it was interesting, they talk about permit the conveyor to make several revolutions. If you're working on a 200, 300 foot, 400 foot center conveyor, you probably have the time to sit and watch that run. But if you're working on an overland system or a mainline belt coming out of a mine, it'd take all night to watch that son of a gun go around 3 times. So you just watch it long enough to where you feel comfortable that the belt's doing what you ask it to do. You set the idlers, you figure the idler you want to work with, you make the adjustment, you watch it run, you make a small adjustment. If it isn't enough, you make another adjustment and see if it pulls over. There is a point where you'll adjust the conveyor to the point, or an idler to the point that the belt will do strange things to you. So you just do it easy until you achieve what you're looking for. And if you overcorrect, then just move it back a little bit. It's pretty simple. You see where you can get a feel for where it starts to move out. So you start there and move it back a little. When you're comfortable with that one, move to the next idler. Move it up the idler sets until you get it adjusted to where you want it to be. Sometimes you can do it with one idler, but oftentimes it takes 2 or 3, maybe even 4 idlers to make the adjustments. And if your system is seriously skewed, otherwise if it's not really in line or if it's kind of leaning on one side or the other, you may not be able to do it by adjusting the idlers. As far as from side to side, you may have to do some elevation on the side of the conveyor to lift it up. Techniques of tracking, we use self-training return idlers, which is the safest type of idler to use in the system. If you have too much tension in the belt, so that the belt sits high up on the idlers and you can't get a grip on it, it's pretty hard to do it on the return side. You've got to have some friction to cause the belt to move. The other thing would be is if your belt's cupped and sitting up on those points, you've got to modify your system. Self-training trough idlers. This is another one of those little things where you talk to people, and some people are all for it, some people are against it. Point of the fact is, a self-training trough idler has to sit higher in the system in order to operate. So it puts more edge stress on the belt. It can be a source of idler junction failure. So if you're going to use them in the proper places and use them sparingly. Never ever put a trough training idler in a high tension area. For instance, if you have a conveyor system that has this kind of a profile, this area right in here is the highest tension area in that system. If you put a troughing trainer right there, I guarantee you get 3 belts for the price of 1 and you get it very quickly. Don't put it close, again, like transitions. Think of those transition areas. You're going into your pulley here. You don't want to put it anywhere close to this transition area. Again, for the same reason we've discussed earlier, that effectively shortens up the transitions. So be careful with them. You can put so many in a system that it can override the belt's capability for load support. Called out to a grain elevator, and we were in the basement. This is a long system. It was about 1,000 feet on centers. And the guy says, I'm having a problem with my belt. It's failing on me. And we looked at the back side of the belt. You all saw what idler junction failure looks like. If we looked at the back side of the belt, it looked just like that. And you look at that and you can tell him what the problem is. We checked these transitions. They were good. We checked several other things. But he had troughing trainers every 20 feet down the length of that conveyor system. And it eventually just wore the belt down. It couldn't take it.
Training devices on the return side. If the belt is cupped and you have a return side trainer that takes into account manipulating the belt by contact with the edge of the belt, you'll get very little, if no, response, and frankly, it's just going to get in the way. If you have a type of trainer that will help manipulate the belt from the center of the belt, then you'll have better success with a return side trainer on a cupped style belt. Reason being is that on cupped belts, you don't have a whole lot of tension left on the outside edges of the belt. So truthfully, if you have, I've been in circumstances where I've been asked to facilitate training a belt with a severely cupped. You got that cupping on the return side, it's quite prevalent. First thing that I recommend to the customer is that they got to figure out why the belt is cupped and replace the belt.
If the cupping gets beyond a certain point, you might as well take it out because you'll never get it to run on return. It just won't work. Some of the other things we do, of course, we knock the troughing idlers. We've talked about that. Tilting. It's something we haven't talked about. If you have a belt that is too stiff to lay down in the troughing idlers, so that it lays up, sets up in that position where it's not making full contact. So you have the troughing idler here. Well, that's a modified troughing idler. And your belt is hitting here, maybe a little bit here and a little bit here. If you don't have good full contact with these rolls, you can't trough it. Well, one thing you can do is you can tilt the belt or tilt the idler forward in the direction of belt travel 2 degrees. And what that does is it forces the belt, it hits here, and the way the belt is set up, it'll push it down into the system. Now that isn't good on your splices, it isn't good on your idlers, it isn't particularly good on your piece of belt. But if you have a piece of belt that you can't get to trough, you can't get to train because of that, you can actually tilt those idlers forward and run it that way until you get the belt settled and then move it back to vertical. Some idler manufacturers come with a 2 degree tilt in their idlers already. Most, though, I think nowadays are just straight up. Just stick a little washer or two in the back of them and you're in good shape.
How many idlers do you need to tilt with?
I'd start with every 4th one, and if I need more, then I come back and tilt back from that point.
Once again, I think we need to impress upon everybody that these are recommendations that can be done. In the real world application, whether they're going to be done or not is quite the different matter. You could convince a customer that 2 degree tilt is what they're going to need on a, say, a stacker conveyor at a quarry application. I would think that you'd be hard pressed to get them to take out the shims once the belt's doing what it's supposed to do.
Self-training return idlers, these are just troughing trainers. Now, if we were to walk out of here tomorrow and go to 15 sand and gravel plants, of those 15, probably 12 of them would have troughing trainers in their systems, and of those 12 with troughing trainer systems in their systems, maybe 2 of them would have troughing trainers that were really operating. The rest of them would be frozen up, not working, or tied off. I hate to see them in a system. They do sell belt, but they don't solve the problem a lot of times. So, use them sparingly and use them wisely. We talked about knocking the idlers. Any questions about this? I think it's been covered pretty well. Tilting the idler, 2 degrees maximum. That just forces that belt into the idler. And like I say, if you can do it about every 4th, we had a power plant in Pennsylvania. Bless their hearts, sometimes engineers just will not listen. They'll design a conveyor system that's 4,000 feet long and have 200 foot of lift in it and design it 36 inches wide. This thing requires a 750 pound working tension belt. Nobody in this country makes one that'll work there, but they insist they've got to have it. So then you modify your carcass a little bit to try to get it done, and invariably it jumps up and bites you And so you run out and you do things like this to make it run for them so that they can run some coal over it and finally break it in and it'll work for them later. But this will happen, and we do it more than I like to talk about. Threading and moving return idlers. Remember now, we've talked about the threading part. Sometimes your system is just not level. Sometimes the system's unlevel. So remember again, the belt runs to the side of the conveyor that it touches first, so it's perfectly legal then to raise one of those return idlers up in the system. So now you have a high point, have something for that belt to run to. That's legal, logical, and works more often than not. So don't be afraid to move them not only in a horizontal, but vertically to get the results you're looking for.